Good morning, everybody. Welcome to the Drought Conditions webinar. Give folks just another minute or two to get connected. Looks like a few more people are trickling in, and then we will go ahead and get started. All right, it's 10:03. Why don't we get things rolling? Welcome everybody to this Drought Conditions webinar update. We did a similar discussion back in January and then early March, and then with the current conditions decided it would be appropriate for us to pull the panelists back together and go through similar information again to update everyone on where we stand on drought and what we see out into the future. So we've got the same slew of panelists that we've had before. We have the State Climatologist, Justin Glisson, we have Dennis Toddy from USDA up in Ames, John Nania from the US Geological Survey, Mike Gannon from the Iowa Geological Survey, and Mike Anderson with Iowa DNR. So with that, I think we're just going to jump into the discussion. If you have questions as we go along, please feel free to put them into the Q&A tab at the bottom, and we will flag those. And if they're appropriate to answer as we go along, we'll answer them as we go along. We're going to leave time at the end for questions to deal with at the end, if there are questions that make sense to deal with at the end. So feel free to type your questions in as we go. Just a reminder that certainly no later than tomorrow morning, we will have all of these presentations that you see today available and up online at the DNR website. If you just go to Iowa DNR on the web and then you put in the little search box, water summary update, we'll have a link to a single PDF that has all of the presentation materials from today available for you to have to look at. So if you missed something and you didn't get something written down, you can either ask in the Q&A or just sit tight till first thing tomorrow morning and you'll have all that information available. So with that, excuse me, with that, we're going to go ahead and get started. Justin, do you know if the secretary is available?
I believe I see his number on there.
Okay. We're going to start with a couple of comments from Secretary of Agriculture, Nag. Working on getting.
Good morning, Tim. Good morning, Tim. I'm here. Can you hear me? Yes, thank you.
Absolutely
Good morning, everybody. Great, and I am on the road this morning, and so I'm just calling in, but I did, thanks for the opportunity to kick things off this morning. Again, I really appreciate this ongoing series of the webinars here, and thanks everybody who will be participating today for your efforts to certainly transition, most importantly, to keep folks informed of what's happening and give everybody a chance to ask questions this morning and have a good discussion. So thank you for that. The data that you all collect, all the partners collect, are valuable insights for our farmers, obviously during a very, very critical time of year with planting as we move into the growing season here. We had a very fast start to the planting season. Of course, that was in large part due to the fact that it was dry. 97% of the corn and 89% of the soybeans are in as of Monday. That's still, though, about 1 million acres of soybeans that need to go in the ground. That's no small thing. And I know we farm in Northwest Iowa, Palo Alto County. I know we planted a lot of corn and soybeans into dry ground and knew that we needed some rain to get that going. And it's great to see widespread precipitation now. However, y'all know there's still some very, very dry spots, and we don't correct these things with 1 or 2 rains or even just several weeks worth of precipitation. So we need to watch this very, very closely. We know that we'll need consistent rainfall over several weeks, longer term, to deal with those longer term precipitation deficits and increased water demands. Obviously, as we get into the growing season and warmer months become more and more of an issue. So again, I just wanted to start things off this morning by thanking you all for keeping an eye on this situation, keeping us informed, and being a good resource for producers and for all Iowans. So of course, I want to offer up, if to those of you watching and participating today, if there's anything that my office can do, please do not hesitate to reach out to us and certainly Dr. Glisson if there's resources that we can provide or thoughts that you have for us. So with that, Jim, I'll turn it back to you. Thanks everybody for participating today.
Secretary Nag, thank you very much for those comments. It's nice to get things kicked off that way. And yeah, this is a great opportunity to show the collaboration we've got between state and federal partners across different agencies of those parts of the government. So thanks for those comments. We're going to jump right into it. We're going to start with a presentation from Justin Glisson, who is our state climatologist. And we'll let him roll first. And again, if you've got questions as he goes through this information, type them into the Q&A tab at the bottom, and we will flag those and get them responded to. And we're also recording the presentation, so the recorded presentation and the presentation materials will all be available. So Justin, over to you.
Good morning, everyone. Tim, are my slides up?
Yes, they are.
Perfect. All right, let's get started in the interest of time. So yes, thank you all for being here. This is a great regional and federal and state collaboration. So what I'll talk about today are some brief highlights of 2020, how we got into the drought situation, and then talk about just briefly the new normals that have come out, the 1991 to 2020 30-year climate decade. Then we'll talk about current conditions, where we are in terms of precipitation, recent temperatures, subsoil moisture profiles, all of those hydrological, meteorological components that go into drought monitoring. Look at the 2020-2021 drought and its evolution, and then kind of give a summary and tee up my panelists moving forward. Okay. So briefly, I'll show you one map for 2020. This is the annual departure precipitation. So wherever you see warm colors on the map, that's where we're below average for the year. Iowa is centered right in the middle, in case it's hard to see the borders there. Wherever you see those cooler colors, that's where we're wetter than average. Well, we only see northeastern Iowa with above average precipitation for 2020. So it was a relatively dry year for the state. But if we look at our 9 climate divisions that make up the state, you look at northwest Iowa, west central Iowa, and southwest Iowa, the 9th, and 8th driest years on record going back 126 years. So very dry conditions. That's where we started to see drought form May, June, July of last year. Now, the only difference there was we were coming off 2 very wet years, 2018 second wettest year, 2019 12th wettest year. Put those 2 years together, second wettest year, 2 calendar years on record. We were coming into the growing season with full subsoil moisture profiles, near record capacity. We're not there this year, and we are continually being in drought. So that's something that we always keep in the back of our mind. Now, if we look at spring 2020 so far, and these are preliminary numbers, especially for May, we look at March in terms of precipitation, about a ½ an inch above average, so 34th wettest in 149 years. Then we look at April, 2 inches below average, and these are the numbers on the bottom here. 16th driest on record. If we look at north central, northeast, and central Iowa, the top 5 driest Aprils on record. So that's where we started to see drought conditions expand from the existing D1 conditions in northwestern Iowa, also that D2 core. In general, if we look at temperatures and precipitation for the spring season so far, with about a week and a half to, or about a week to go, we're about average. We're about right in the middle of the distribution. But when you break down those months, we have seen some wetter periods for parts of the state, but also drier periods for the driest parts of the state. What we use to rank our months, our weeks, our years are what we call climate normals. And climate normals serve as 2 purposes: as a reference period for monitoring current weather and climate. So it gives us an idea of a 30-year average of how extreme a weather event is, or how extreme a period of time is versus the average for a given station, a given county, a given climate division, and the state. And they're also a good description of expected climate at a location in a given season. So they give us an idea of what we should expect. Again, climate is what we expect, weather is what we get. The science behind these normals are the same as the previous normal period, 1981 to 2010, with only minor tweaks in the calculation technique. Normals have changed from the previous cycle, but taking in the 2 previous decades and adding the third, 2010 to 2020, we're actually having 2/3 overlap. So it does mute considerable change in the temperature and precipitation fields. So if we look at the difference between the 1991 to 2020 climate decade versus 1981 to 2010, top left here is temperature. So wherever you see red, that's where we've seen an increase, degree Fahrenheit, in temperature. So as you can see across much of the United States, we've seen an increase in the temperature. Now, an interesting thing is if you break down regionally, the upper Midwest, the Dakotas, we've actually seen cooler temperatures between the 2 climate decades. And then interestingly enough, in southeastern Iowa, we've also seen cooler temperatures versus those 2 decades. Now on the precipitation front, we've actually seen in the upper Midwest and over much of Iowa an increase in the percentage of precipitation that we've seen from the old climate decade to the new. So warmer and generally wetter are what we've seen across the state, with pockets of cooler and drier. But wholesale, that's what we're seeing across much of the upper Midwest, and those will be drivers for our weather moving forward. Okay, now let's look at current conditions. Where we are in terms of temperatures, the last 30 days, on the right-hand side here, generally the average temperature has been in the 55 to 65 degree range. On the right-hand side here, this gives us a departure. And again, these are using the new climate normals, 1991 to 2020. We've actually been slightly above average temperature-wise over the last 30 days, anywhere from 1 to 2 degrees. Now you'll remember late part of April, early part of May, jet streams stuck further south, pretty dry conditions, but also generally cooler conditions. A jet stream has moved north. We've formed a thermal bulge, which allows moisture and temperatures to increase, and hence we've had a more active storm track. And given that more active storm track, if we look at the precipitation that we've seen across the state, on the left hand here is the total precipitation for the state of Iowa. Wherever you see those red colors, it's counterintuitive given drought conditions. Wherever you see those red colors, that's where we've seen anywhere from 6 to 8 inches of precipitation, versus the green color up in northwestern Iowa, anywhere from 1/2 an inch up to 2 inches. So northwestern Iowa, northeastern Iowa continue to be the driest parts of the state as reflected in the drought monitor. The 2 maps on the right-hand side here, wherever you see warmer colors, that's where we're below average precipitation-wise. So as you can see, besides the southeastern corner, the entire state is seeing drier than normal conditions over 30 days and at longer time spans. Now, if we look out 6 months, Again, we're seeing the driest conditions across northern Iowa. Specifically, interestingly enough, given that northeastern Iowa was the wettest part of the state in 2020, that's where we've seen the more recent or up to 6-month driest conditions, anywhere from 2 to 4 inches locally above that. And then we have some above average precipitation in the southwestern corner and southeastern corner, wherever you see gray, near normal, going back 6 months. So if we look at the 0 to 200 centimeter or 0 to 80 inch subsoil moisture profiles, and these are percentiles. So if you think of a sponge, 100% would be soaked. Wherever you see those darkest reds on there, central Iowa moving up into northern Iowa, percentiles below 20th. So 80% capacity in that subsoil moisture profile. So very dry conditions that we've seen persistently into this growing season and effectively from last fall. If we look at topsoil moisture, a similar message here, very dry conditions in northern Iowa. As we get into the warmer part of the season, we can get an atmospheric thirst that forms, which will extract topsoil moisture a lot faster, especially if we get into windier, lower relative humidity days. So we have to take these into account when we're monitoring for drought and dryness conditions, as we have multiple variables that go into that monitoring. If we look at a 3-month difference in the column, or if you look at the subsoil profile, we have seen an increase in western Iowa as a more active storm track has been locked in Kansas into Nebraska. Western Iowa is benefiting a little from that. You look across the eastern part of the state, we do see drier conditions creeping in from 3 months ago. So again, these go into where we've seen abnormally dry conditions start to expand south, along with that new D1 core in northeastern Iowa. So if we look at 2020, when the drought started, we had peak of drought with that D3 extreme drought region in west central Iowa, September 8th, after a very dry summertime. August was the 3rd driest August on record, which lent to those very dry conditions in the western part of the state. And then by the end of 2020, after a effectively ho-hum fall, not as wet as we would expect, as the trends have shown us, we did see some improvement in western Iowa, and especially in eastern Iowa, where we did see a storm track lock in and timely rainfalls over the summer or over the fall months towards the end of the year. So that's where we were at the end of 2020. Where we stand now, the last map, May 18th, we still have that D2 severe drought corridor up in northwestern Iowa, where we have precipitation deficits going back 12 to 14 months on the order of 8 to 12 inches. So pretty substantial precipitation deficits there. Then we look at northeastern Iowa, where we've seen the newest expansion of D1 conditions as of a few weeks ago, given the dryness creeping in up there and precipitation deficits going back 6 months, 4 to 6, even up to 8 inches. We have seen expansion of D0 south, but as we shifted the storm track over the last several weeks, we have actually removed some D0 from southern Iowa, which is reflected where that white color is. And as a reminder, that D0 is abnormally dry. It's not drought, but it's a signal for us to keep an eye on the driest conditions, because those can rapidly turn to drought if we do get into warm and dry conditions. So if we look at the drought categories, it's always important to look at how they're based. It's a percentile based on history. So if we look at D4 exceptional drought, that's greater than 50 years, once in 50 years, once in 100 years. If you look at the newest D4 category up in North Dakota, they've only had D4 3 times in history. So in the observational record. So that gives you an idea of the pervasiveness of D4. And then as the drought categories decrease, that tells you that D1 once every 5 to 10 years, D2 once per 10 to 20 years. D0 we see in parts of the state once per 3 to 5 years. And we've seen that going back, even back to 2012, the last widespread and pretty devastating drought. In terms of where we are, it's a balancing act. Short-term improvement, yes, we've had rainfall, steady rainfall, but not not large totals of rainfall versus the longer-term deficits that I've mentioned going back 6, 12, 14 months. So as a drought monitoring process, we want a convergence of evidence of all of the, or of most of the moisture profiles, subsoil profiles, also meteorological rainfall, stream flows, and my colleagues will get into those later. But we want them all to point in one direction to get the best map, and that's where monitoring really comes into play. I'll skip this one and go to the Northwestern Drought Time Series. This is where we've seen the most widespread drought going back to last year at this time. So we saw D0 start to form 1st of May last year, and then really explode after a very dry fall. The vertical axis there is the percent coverage of the climate division in Northwestern Iowa. And the bottom axis is the date. So we saw D3 extreme drought 1st of October really start to increase. And then as we got into a wet period towards March and April, we actually improved that region up to D2, but still, again, pretty substantial precipitation deficits along with dry subsoils. Now, if we look at the change map since last year, wherever you see those warm colors, that's where we've seen a degradation in drought conditions. So widespread drought in the southwestern states, also in the Dakotas, Wyoming, Montana. And we've seen improvement in Colorado and Nebraska and Kansas. And then we look at the state of Iowa, an increase in the amount of drought that we've seen versus last year. If we look going back 2 months to our last drought webinar, we've seen improvement in Western Iowa as reflected in that green color, 1 category improvement from D3 to D2, and then some removal of D2 to D1. Where we stand out here is in central Iowa into northeastern Iowa, where we've seen a degradation in drought conditions. So drier than normal conditions, and then D1 introduced a few weeks ago. Now, expected precipitation. So spring into early summer is the wettest part of the year for Iowa. April to August, 2/3 of our precipitation falls. If we look at the 30-year average, we expect from April to July, 14 to 18 inches. Now, on the left hand here, that's the 1981 to 2010 climatological decade. If we look at, considering row crops require around 25 inches of water through their physiological processes, we can see rapid degradation as corn and beans use up subsoil moisture if we don't get into regular rainfalls. Now, an interesting thing here is if we shift to the 1991 to 2020 climatological decade, we actually increase the amount of precipitation that falls over the state, especially in northeastern Iowa, where we have a core of 19 to 20 inches versus 17 to 18 inches in the previous climate decade. So finally, I'll conclude here. Drought issues continue. We've shifted into a more active storm track that's brought much needed rainfall, but longer term deficits mean that drought conditions will persist unless we get into a stretch of consistent, good duration rainfall in terms of thunderstorms for a period of months. This will not be extinguished in weeks given the seasonal drought. The interesting thing is, with lack of thunderstorms, we've had a pretty good lack of severe weather from March to April. Now, we did have some severe storms yesterday, but with lack of severe storms, that means lack of precipitation. So we do get into dry conditions. Dr. Toddy will get into short-term outlooks, but full subsoil profiles helped us immensely last year as we started to dry out. We don't have that source of moisture this year. So we really do need to see consistent and above average rainfalls to start chipping away at the drought conditions. So we should see drought conditions persisting into the growing and through the growing season. Finally, Google the Climatology Bureau, all kinds of weather records and plots on there. Here's my contact information. And with that, I will throw it back to Tim.
Justin, thank you. Appreciate that. hopefully that provides everyone a quick snapshot and overview of how we got to where we are and what we're experiencing at the current moment. The order of the discussion this morning is purposeful in that we start with precipitation, and then we think physically precipitation initially leads to stream flow and then to groundwater. So we're going to talk about stream flow next with John Nania from the US Geological Survey. And then after he's done, Mike Gannon's going to talk about groundwater changes. So that's what we're going to talk about next. And again, if you got questions that you're formulating, feel free to type those into the Q&A box, and we'll get to those either as we go along or once we wrap up toward the end of the hour. So John, over to you.
Okay, all right. Thanks, Tim. That was a good lead in from Justin for sure. So you'll see some similarities here from the climate data into stream flow conditions. So, okay, so I'm going to give a briefing on our current stream flow conditions with a few comparisons to some past flows, just to give you an idea kind of where we stand now compared to, say, like the 2012 drought conditions back then. So, and we know stream flow conditions are important for many reasons: irrigation, groundwater recharge, wastewater allocations, many reasons. But I'm going to first show you our map of stream gauges across the state. We've got about 140 locations where we monitor stream flow, continuous discharge in the river, that is. And this map shows those locations, and the locations with colors on them are sites that have at least 30 years of record, where we can start to make comparisons to past stream flows. And that's the threshold we use so that we're not biasing on a shorter period of a wet period or a dry period. So the redder colors are more drier conditions, and the bluers are more wet conditions. So you can start to see in this map here, especially if you look at Northwest Iowa, how the redder colors are starting to appear. And then we can make some assumptions throughout the rest of the state by filling in the gaps based on these conditions. And you can see our current conditions right now, as of yesterday's average flows. You can see Western Iowa especially is showing some lower flow conditions. And this map really is very similar to the map Justin showed as far as the departure from average precipitation. It was really very similar, I noticed, on the low flow here compared to the lower precip data that Justin was showing. So, and then when we start to talk about low flows, we oftentimes use the last 7 days as an average. I haven't really been showing that on my last presentations, but I think it's good to show that now, especially since the last couple of days we've had some precipitation. And when we look at the last 7-day average, it really kind of shows how we've been over that time, and just so that the last day really isn't reflecting any short rain event or anything. So we can pull up the 7-day average stream flow, and then you start to see a little bit more drier conditions up in the northern part of the state and on the lower Des Moines River as well. So I'll be talking about some of the 7-day average stream flows on some later slides as well. But a lot of times we look at the last 7-day average. So, and this is the average from yesterday, basically. So that average stream flow changes throughout the year. And I'll show you a little bit later how that average does change at a few particular sites. So, but that's also something to keep in mind. So the average now is different than, say, the average in the fall. Okay. And then we can start to look back at some monthly comparisons as well. On the right shows our monthly summary from April, and on the left shows our monthly summary from April a year ago. So you can see we are quite a bit drier than about a year ago at this time for April, that is. And then we can even look further back, like how do we compare to April 2012 when we know we had a dry period creeping in later in 2012, and you can see we are certainly drier in Northwest Iowa for sure as compared to 2012. So as of April. And then what I'd like to highlight as well is just a few select sites, especially in Northwest Iowa, and show you how we are at a few select sites. It'll give you an idea of how things change throughout the year, especially with flow conditions as well. So the first site I'd highlight is the Rock River near Rock Valley. And there's a lot going on in this image here, but the black line represents our stream flow from current, the actual stream flow that occurred up until yesterday back through 2020. And those greens and the blues and the orange represents those different flow regimes of low and higher flows. So on the left is again 2020 to 2021, and you can see currently that we're just above starting to get the low flows at Rock Valley. So, but if you compare that to 2012, where we were at this time, you can see we're quite a bit higher back in 2012 at this time up for the Rock Valley stations. We had a good spring event there, and we're quite a bit higher. So we are sitting a bit lower right now for the Rock Valley station as compared to 2012. And then if we look at the Des Moines River at Stratford, where we are in those low flow regimes, you can see right now at the Des Moines River at Stratford, we are in that low flow regime right now. And then, as Justin said, last year the precip really shut down in August, so we really dipped down into some really low flows last fall, and then kind of crept up a little bit now, but still in some low flow regimes at the Des Moines River at Stratford. Again, and then if you compare back to 2012, we were in the normal flow regimes back in 2012 for Stratford. And then just to highlight the Missouri River, it's kind of a different beast since it's regulated out of Gavin's Point, but I just wanted to show where we sit with the Missouri River, and it's in the normal flow regime there right now, but it's a different beast because it's regulated out of Gavin's Point. But I just did want to do a quick highlight of the Missouri River near Sioux City there. And then I know we're talking about stream flows, but lakes are another good indicator of drier conditions as well. We've got two lakes here that I'm highlighting that we monitor: West Okoboji Lake and Clear Lake. And the right side of the graphs shows our current levels, and we are sitting a little bit higher than some of our other drier periods of 2012, and then actually back in the 80s as well, and in the 70s. So we're starting to dip down a little bit, but we are still sitting a little bit above those drier conditions at West Okoboji Lake, and then the same for Clear Lake as well. Okay. And then just to conclude, we certainly are seeing some low flow conditions for this time of the year. And in fact, about 25% of our sites across the state are showing low flow conditions for this time of the year, with the majority of those being in Western Iowa. So with that, I just wanted to do a high level overview of our current stream flow conditions, and I'll turn it back over to Tim. Yeah.
John, thanks for that. As we continue the discussion here, please keep in mind that John will be around, and if you've got questions about specific locations in the state, we'll be happy to try to answer those. If not, I'm sure John can follow up with any one of you afterwards to answer questions, and to also maybe walk you through how you can generate a lot of these maps yourself off of the USGS website. All this data is publicly available, and it's fairly simple to create these maps that help everyone understand what's going on. So we'd be happy to do that for you if that's something you want to get under your belt. With that, I'm going to turn to Mike Gannon, who's a hydrogeologist with the Iowa Geological Survey. Talk a little bit about groundwater conditions, and then Mike Anderson is going to talk about some irrigation outlook. So Mike, to you. I see your Zoom screen, Mike, but not your presentation screen.
There we go. Is that better?
There you
Tim?
go. That's it. That's it, Mike.
Excellent. Sorry, I should wear my glasses. It's a little bit more effective. Well, anyway, yeah, my task is to kind of touch on the shallow groundwater conditions, certainly related to precip and especially the stream flows. Kind of starting back early April, you could still see Northwest Iowa in severe, and my categories are a little different than the rest of the drought. I only have 3 categories. I'm lacking data. I wish I had as much as some of the other folks, but you can see it kind of expanded into May. You know, Justin's precip data across Iowa, especially northern Iowa, created additional, you know, moderate to severe droughts, especially over northwest and central Iowa. We're seeing deterioration of groundwater conditions in those areas. This is along the Ocheyedan River. I'll kind of keep my data sources anonymous. I don't like to share rural water systems and public water systems unless they give me permission. But you can see this is along the Ocheyedan River, northwest Iowa, Osceola County, and getting close. Our datum is kind of that 2012 drought. And fortunately for them, they had a pretty good flood event last summer, but you can see the deterioration, and we're still hovering about 1.5 to 2 feet above the 2012 drought. But remember, what affects shallow groundwater is not only the precip and recharge, it's also the usage. And we're getting ready to start a very high usage period, especially with livestock. If it gets hot and they have to start spraying livestock to cool them off, their water usage can go up 50% or higher. So this is not a good situation to get in. You know, this is another along the Floyd River in eastern Sioux County. You can see still maybe a slight improvement, but still getting pretty close to that 2012 drought level. This shows the same well field, but with a recharge basin that actually provides a little buffer from the drought. That little dip you see is when the recharge basin or wetland freezes, and in some cases can freeze solid. That obviously affects the groundwater levels when the wells are pumping. But you have about a 3 foot buffer there above the drought level as compared to without the wetland. Now 3 feet or 1.5 or 2 feet doesn't seem like much, but remember these wells, the saturated thickness in many cases is 15 to 20 feet. So a foot or two can make the difference between pumping 24/7 or having to shut wells off every 6 to 8 hours and allow them to recover. So this kind of shows the benefit of maybe a drought resiliency. This is Palo Alto County. Very, very dry. I was up there just over Monday and Tuesday doing some field work, and you can see things have deteriorated very rapidly. This is a static level, and we're getting down right just barely above the 2012 drought. That area is in desperate need. They got about 1 inch of rainfall last weekend. The crops are looking okay, but the sand and gravel pits and ponds are at minimum 5 feet lower than normal. It is the really desperate situation, I think, as far as groundwater. They really need it. In many of these public and rural water systems, that's their only source of water. This is in central Iowa, Boone County, and you can see things have dropped off. Again, that little dip there, I think, is related to the winter months, but still we're getting close to the 2012 drought. Boone County, it's along the Boone River. The wells there are really connected to the river, almost an instantaneous response. So with the river levels being down, the groundwater levels are down. I guess some of the strategies, probably the first thing I would do if I'm a water operator or a water manager, make sure your specific capacities are holding up. If they've dropped off any 15 to 20% from normal, I would seriously consider doing some well rehab, getting those specific capacities, gallons per minute per foot drawdown. If those drop, it makes the drought even worse. Some other strategies, obviously some additional wells, hopefully not too close to your existing well field. Secondary sources, if you have them, some deeper wells to draw from. Generally the water quality is a little less, a little poorer in the secondary sources. And then of course, enhancement of storage in groundwater. This is an example of a rock riffle in Sioux Center. And you can see the river stage not only goes up several feet, but that water then expands out into the aquifer, tremendous amount of storage. It allows for probably 12 to 16 months of additional storage for their shallow alluvial well field. This is a recharge basin in Rock Valley Rural Water. Sorry, I had to include the name in this one. It was on the slide. But you can see the 2012 drought off to the right. When that basin's full after rainfall, basically you're seeing anywhere from 10 to 15 foot rise in the groundwater level. So again, tremendous amount of storage, but those take some time to get set up. It's kind of bad when you're looking at drought strategy when you're in a drought, but they are effective. This shows some of the modeling at a particular site along the Floyd River. You can see we look at, where do you get the biggest bang for your buck? On the left, you see the recharge basins providing some help to the production wells there in pink, but probably less than a foot of available drawdown, as opposed to a lowhead dam or a rock riffle where we're seeing 4 to 5 feet. So it just kind of helps us to prioritize which strategy is best for a particular well field. And then we quantify that. And that is all I have, Tim.
Thanks, Mike. I appreciate that. I know we're going through these presentations fairly quickly, but we do want to try to roll through the entire session here by about 11, and we'll be around for questions. You can ask them as we go, or we'll have a chance at the end to get some questions as well. Going to hear a short presentation from Mike Anderson on some irrigation outlooks, and then some climate outlooks from Dennis Toddy from USDA. So first we'll go to Michael Anderson, and then we'll go to Dennis Toddy, and we'll just keep rolling along. So Michael, you're up.
Good morning. Can you hear me now?
Sure can. You're good.
Okay, wonderful. Michael Anderson, and I work with the water allocation group in the water supply engineering part of Iowa DNR. And I was asked to talk a little bit this morning about our general irrigation outlook. So some of this may sound a little repetitious, but just realize that the outlook is fair with us being worried, but not restricting anything at this point. All of DNR's regulatory regime really depends
Mike, Mike,
yes.
Michael, can you switch to the presentation view so we can see just the slide and not the side panel?
Is that better?
There you go. Yep, that's it.
Yep. All of DNR's regulatory strategy depends on data we have from monitoring, especially the US Geological Survey, and their streamflow data is very vital to any decisions that DNR ever makes. We have data going back to the 1900s and the use of USGS's statistical analysis. So realize when we talk about potential irrigation regulation, we're depending on a series of statistics from the USGS. And this map was from about 2 months ago, but again, showing levels of streams and where they're sitting. When we talk about irrigation, you begin to see some of the newest irrigation wells we've been having. I have a data set here taking out Missouri River irrigation, but showing a lot of new irrigation along a lot of the alluvial streams in western, especially northwest Iowa. And we begin to see that irrigation has become more and more prominent and more needed over the last 10 years or so. We also begin to see a large expansion of rural water systems, especially in the west and northwestern part of the state, just their overall service area and the amount of water they're utilizing. And I'll have a slide covering that to that extent. Nothing wrong with that, but it's just showing where some of the pressure is and some of the things that as an agency we have to watch. Mentioning some of the rural water districts out in western Iowa. And this graph kind of gives a trend over the last 8 years of the amount of water usage specific to rural water districts. You see over the last couple of years, we have a bit of a dip, but you also see a long-term trend towards an increase. And this is just accumulating different districts and their overall usage. So again, just something, not major problems, but something we have to watch, especially given what Justin talked about and what John talked about Northwest Iowa just having less rainfall, so we have to watch it. Without getting into too many rural water systems, we have a couple that we watch very closely just to mark and mark if something may need to be done. We have an area where the Rock River is confluence with the Big Sioux River and a couple of different rural water districts and a lot of irrigators in that area. So it's something we keep track of closely. This graph showing overall usage that we've tracked for about 10 years or so. Once again, not showing major problems going into 2021, but just trends that we watch. And I keep emphasizing that, but that's really how we are sitting today. I would have to categorize. We're in a fair condition and we're watching things. Now, when we get into regulatory authority, the DNR, essentially what we rely on is a concept of protected flow, and we're asked to protect ordinary household and livestock use, fish and wildlife uses, recreational uses, and any other uses of a public nature. Without getting into a lot of regulatory details, this is found in the administrative code at 52.8, and its primary application is to irrigation, which is what I was asked to touch on today. The department uses a series of flow warnings, and potentially, if droughts get bad enough, we can proceed to flow cutoffs. That doesn't happen very often, but it can happen. Realizing protected flows are meant to only apply about 1 out of every 6 years, and flow cutoffs are much less used, more like once out of every 10 to 15 years. Protected flows are set up at a system of the US GS gauges as shown on this graphic. We have a low of 2 CFS. I believe that's over on Beaver Creek, and you see a high of the Iowa River at Wapello. If we move into drought situations, irrigation, we can get into things like postponing irrigation or helping systems set up a series of surcharges. What we typically do is work county by county or stream basin by stream basin to cooperate with all nearby permitted irrigators so that no one is taken by surprise. Code authority allows DNR to limit irrigation to 1 inch per irrigated acre per week. It's not something that's ever used lightly by DNR. It's something we tend to would not want to go into until we had worked with a lot of the irrigators in an area. Once again, high level for today's meeting, irrigation situation is fair. As John's presentation showing the stream gauges showed, we have a lot of streams that are, well, they're a little dry, they're fairly high, as compared to where the protected flows sit. And we're not really near restricting anyone right now. As Mike Gannon touched on, though, the problem that is, I suppose, in the back of most of our minds is that usage can go up markedly, especially as we move through June and move into July. The temperature gets higher, the usage can go up, and things like especially potentially livestock needs can really start putting pressure on the system. So that's why we're all here today. One of the reasons we just keep watching things closely. My contact and a couple of my colleagues that help follow this is located on this slide, and as Tim has alluded to, this will be on our website tomorrow. Once again, just telling you what I told you. Outlook is fair. We're watching things. Thank you.
Michael, thanks. I appreciate that. As the irrigation season continues, we will keep track of what's going on, and we can certainly emphasize and spend more time on that as if things start to unravel a little bit. I'm going to turn the discussion over to Dennis Toddy, who's with the USDA Midwest Climate Hub up in Ames, talk about some climate outlooks, and then we'll circle back to questions. I know we have one about harmful algae blooms, cyanotoxin. We'll take that up here in a moment. So Dennis, I will turn this over to you.
Okay, thanks. Are you seeing the preview slide or the full version of my slides?
I see the full version.
Excellent. Okay.
Yep.
Good morning, everyone. Glad to have a chance to chat and to address some of the issues here. We're going to get right into it here, talking about where we've heard about where we are right now, comparison. Now we're looking at where are we going? What's next on the list? Briefly, Justin showed you the Iowa view. I like giving a little larger view of where we are from a drought situation. Upper left-hand side is the whole US view. Lower right-hand side is the north central US. Iowa has some similar drought issues to some areas in the northern Corn Belt up in the Great Lakes, where not terrible problems, but there's some issues there with some dryness. Northern Plains is the worst area in the north central US right now, and then the whole desert Southwest and much of the western US, some serious issues. Okay, main points takeaway. We still have drought issues, which you've heard from everyone. And despite recent rainfalls, we really, except for southern and southeastern Iowa, we really haven't improved the situation. The rainfall has been enough to green things up, but from a water standpoint, really hasn't improved the situation. From an outlook standpoint, the La Nina that we were in has weakened. So we are not called neutral conditions, not an El Nino or La Nina, which kind of leads our outlooks wide open. We can't say a lot one way or the other. We're going to talk about that briefly as we go along. And then the outlooks are kind of a steady state right now. We're not showing major improvement, but we're also not showing too much worsening right now. So it's kind of a good news, bad news situation. And then before we hit to the outlooks, one other point I wanted to bring up that's kind of an important one. Justin mentioned and talked about the change in the 30-year normals. We've updated those now. NOAA has updated those, I say we in a general sense, to 91 to 2020. This is for Lamar's, but it shows a rather marked change on what's happening. Justin did mention, and it is true, that we are getting wetter overall. But the new normals for much of Northwest Iowa show this concerning change in the middle of the year. The green bars are the monthly average precipitation. The lines at the top are the monthly average highs, the monthly average lows, and then the monthly averages, so to speak. Sorry about that. We'll go back up here. But there, you'll notice that what happens, whereas the previous normals kind of had this nice normal distribution, July has kind of taken a downturn. That we now, the 30-year average over the last 30 years, we expect to kind of drop off in precipitation. That we're wetter in June and wetter in August, but July, which is our hottest time of year, most time for crop usage. You heard about the livestock issues. That's a concern we have, that there's less expected average precipitation. So that's something we're gonna have to keep an eye on as we go along here. Okay, jumping to the outlooks now. Starting off from where we are right now to the next few months. Temperatures are going to be cooling off into the weekend, quite cool for the holiday weekend. From a precipitation standpoint, we have several chances for precipitation, but the computer models are projecting over the next 7 days. There's been, finally, we've had the shift. Justin also talked about where we've had moisture coming up into the central US. So we're getting, the plains are expecting more precipitation. Iowa, we're in a lot of the bluish categories there, which are around to an inch and a half. That would be nice to get, but the average for this time of year is around an inch of precipitation. So just to hold steady, we need to keep getting an inch, we need to keep getting an inch of precipitation or so on a weekly basis. So this doesn't fix it. This doesn't make it a ton better, but it kind of keeps us going. So now these are computer models, and they've been a little bit iffy sometimes. So continued chances for precipitation, not major amounts, are going to move the needle towards a lot of improvement. Okay, and then again, our probabilities, the rest of the outlooks are all based on probabilities, higher probabilities for wetter or drier than average, or higher probabilities of warmer or colder than average. And we'll jump through this. So here's the next 8 to 14 day, and these next ones are all temperature on the left-hand side, precipitation on the right-hand side. And Iowa for both of these is in the gray area mostly, which is in the near normal for temperature and precipitation. You see some slight variations around the edges of the state, but those are just a couple percentage points difference. So the main thing to focus on is in the week 2 time frame. Near normal conditions are the most likely situation that we would expect at this point. If we jump ahead to the 30-day, you're going to see a common theme on precipitation. Now we switch to EC, which means equal chances for precipitation, means we can't say towards a higher likelihood of wetter or a higher likelihood of drier. So just there's equal chances for below or above average. June, and these are for the month of June. June does have a slightly increased chance of being warmer. So we may be a little bit warmer, but chances for precipitation, we can't say too much about. The 90-day then for temperature and precipitation, this is June, July, August. We have Iowa's largely in that white area, equal chances for temperature and precipitation. So, this is what I was, got to right off the bat. We don't have indications of things getting necessarily that much better. We also don't have indications of things getting that much worse. So it puts us in a tough situation that we can't raise flags and say, we've got problems, we got to deal with this, but we also can't say things are going to get a lot better. They can, it's just we don't have indications of that occurring right now. And that's why there's one other product that also from NOAA's Climate Prediction Center. What is drought likely to do over the next 90 days? That brown area indicates drought likely to continue. We don't see enough improvement to say things are going to get better. This does not mean that drought is going to stay the same all through the year. There will be ebbs and flows. Places will get precipitation or not precipitation. It's just where we think that some level of drought is likely going to stick with us as we go along into the summertime. Okay, so reiteration of take home. Still dry, much of northern Iowa, southern Iowa is improved. Recent recovery in north central Iowa has been limited to, despite having multiple days of rain, the amounts have not been great, or the bigger amounts have been fairly isolated to certain locations. So some places had some improvement, but not widespread. So we still have chances for precipitation, but we need larger amounts for that to improve. And right now we don't see the opportunities for larger amounts. We don't expect a lot of improvement. We're not expecting a lot of worsening. And basically we've got to keep monitoring and start considering options should conditions worsen. So I think that's a prudent thing for us to do at this point. Okay, and then just a reminder of the monthly webinars, which is something else you can attend to get an update from a regional perspective, and contact information for us. We tend to focus on the ag side, so we're happy to help out with any ag issues, but happy to help out collaborating with our partners across the state.
Dennis, thank you. That was great. We are right at straight up 11 o'clock. If folks want to stick around for a little while and ask some questions, we can certainly do that. But as we've mentioned a couple of times, this information will all be available on the DNR website, maybe not yet this afternoon, but probably by the morning. Just go to Iowa DNR just Google Iowa DNR, and there's a search box at the top, and you can type in water summary update, and you'll be able to find all of these presentations there, along with the contact information. And I will speak on behalf of the panelists and say that if you have specific questions or comments or want to pursue one of these issues a little bit further, feel free to reach out directly to any one of the panelists. They'll probably be more than happy to get you information you need, show you where the data is available, exchange some emails if you have a question. So please feel free to do that. I had one question that showed up in the Q&A about harmful algal blooms this year, and what's the probability of those algal blooms. That's not my area of expertise, except to comment on the fact that hotter and drier conditions in surface water can often lead to increased harmful algal blooms. If that becomes a significant issue, we can certainly pull in some of our water quality folks in a future webinar to talk about not only algae, but other water quality issues as related to hydrologic and drought conditions. So if I don't see any other questions in the Q&A box, anybody
Tim, can I do a quick follow-up? The same thing would apply for livestock too, that if you are relying for some surface water for livestock, the lack of water, the lack of overall rainfall could produce some problems for water for livestock and lead to similar issues.
Yeah, and I know Mike Gannon had pointed out the observable decrease in surface water levels in Palo Alto County. And certainly the surface water, we can all look out the windows of our cars as we drive around. Groundwater, obviously you can't see it, but it's also a concern as a water supply issue, especially as it gets warmer and the demand on water starts to creep up. As Mike Gannon alluded to, there's two sides to the equation. There's the supply side and the demand side. And we keep an eye on precipitation and stream flow to monitor the supply side of groundwater. But as it gets warmer and usage creeps up and as demand goes up, we're also pulling on the other side of the equation. So that's something that we want to keep an eye on as well. Any other comments from panelists, you folks that were able to speak this morning? Otherwise, I don't see any other questions in the Q&A box.
I have
Tim.
Yeah. So
go ahead, Justin.
As a panel of experts, we contribute to the drought monitor process each week. So having impact reports on the ground help us coordinate, but also confirm things that we're seeing in our computer models, but also remote sensed fields like subsoil moisture, things like that. So any of those reports that we can get either through our individual offices or through the drought monitor author themselves helps us recommend a map that's more reflective of conditions on the ground.
Excellent point. So things like observations, observations about the status of farm ponds, if you can observe drainage tiles, and if there's any oddities out there, relay those to Justin. And as a contributor to the Iowa part of the US Drought Monitor, those can be included in the drought monitor. So if you see something that's just out of place or unusual, feel free to send that along, because that's one thing that we really don't have regular access to. But if you're out in the field and you see that stuff, having the ability to get that information is useful to us. So appreciate that. I wanted to point out, Justin, you mentioned this in passing, but the climatological summer starts, in about a week, because summer is June, July, August for the climatology side. So
Correct.
pretty soon we'll be past spring. Okay. It doesn't look like there's any more questions out there. So we're going to close down the webinar. There'll be a recording placed later. The attendees are going to get dropped off when we close this down. Panelists, just stick around for a second or two afterwards. But I appreciate everybody attending. Again, if you have questions, comments, or feedback, let us know. We will continue collectively to monitor conditions, and if we, when we feel like it's an appropriate time to do a follow-up on this, then we'll do another one of these, and you all can join us again. And if you've got topics or things that you thought we should have talked about today but didn't, let any one of us know, and we certainly can add those to the agenda the next go around. So thanks, everybody. I'll wrap this up. Panelists, stick around for a second or two. And thanks, everybody, for joining us. And we will see you hopefully in a month, maybe with better news. So thanks, everybody.